All right, so when we're talking about difference of squares, okay, I want to show you some patterns that come when we multiply certain binomials together. So first of all, if you look at these sets of binomials here, what do you notice about each set of binomials? There's a pattern. What's the pattern? What is it? Okay, so the terms are the same, except the signs are opposite. That's right. So we have an x and an x, and a 2 and a 2. So it's kind of like the perfect square trinomials that we just studied, except instead of the signs, everything being the same, the signs are opposite. So let's see what happens when we multiply these together. Well, first terms we get x squared. Then we get negative 2x. Then we get plus 2x. Then we get negative 4. That actually I'm gonna before I simplify that, let's do the other ones. Okay? When I multiply, let's do the first step of all of them. This is 4x squared plus 10x minus 10x minus 25. And hopefully this sort of distribution, this multiplying, is going pretty quick for you now, hopefully. So 3c times 3c is 9c squared plus 3c minus 3c minus 1. Okay, so I just did the first step of all of those because I wanted you to notice something. Now, what do you notice about the second line here in each of these? Just shout it out. You should notice a couple things. At least. Anybody? Okay, they all have a plus and minus. Okay, and are you talking about these middle terms, eh?
Yeah.
Okay, so the middle terms, okay, we have two identical terms except opposite signs, and that happens each time. And when we have that and we're combining them, they actually cancel each other out, right? A positive 2x and a negative 2x, positive 10x and a negative 10x, positive 3c and a negative 3c. So they're actually gone. And the other thing you might notice is that this first term is a perfect square, this last term is a perfect square, this is a perfect square, that's a perfect square, perfect square, perfect square. And the third thing you might notice is this, is that the last term always has a negative sign. Always. For each of these three, and it happens for other examples like this as well. So what that turns out to be is this, x squared minus 4. Over here, this ends up to be 4x squared minus 25. And over here, 9c squared minus 1. So when you look at the answer here, okay, when we have a situation like this where we have exact same terms but opposite signs, we are going to get something called a difference of squares. That's what our answer is going to be when the product, when we multiply. And of course, the difference of squares, a difference means subtraction. That's what a difference means, subtraction. So the terms are subtracted, or they can be rearranged so it looks like there's a subtraction. For example, this could also be written as this. That's actually the exact same, isn't it? So that would still be a difference of squares because it can be written as a difference of two perfect squares. So you might run into that a little bit later, okay? All right, so how does that help us? Well, what that helps us to do is to realize how we ought to factor these difference of squares. Okay? So let's start off here with the difference of squares. And now if I asked you to factor these, this is the process you would think. You think, okay, this is a difference of squares. That means that the factors are going to be binomials where the two terms in the binomials are going to be identical, but the signs are going to be opposite. So that's easy. That's really easy. A difference of squares always factors out the same way. You put the square root of the first term there and there. This is super easy. You put the square root of the last term here and here. Doesn't get much easier than that. And then the signs, one positive, one negative. Done. That's it. That's how you factor a difference of squares. And again, that's because when you multiply these, there's patterns. And it always turns out to be the same. So this one, we're going to have two binomials. The square root of 4x squared is 2x. So that goes there and there. The square root of 25 is 5. That goes there and there. And the square root of 9c squared minus 1 is 3c. And then what's the square root of 1? 1. Yeah, square root of 1 is itself. Plus, minus. And it, whoops, I didn't finish this one. It doesn't matter if you do minus and plus either. It doesn't matter the order of the factors. When they're multiplied, it doesn't matter. Okay? All right? Now that happens every time. I'll give you one quick example for you to do. Okay, I'm just going to make this one up here. 81v to the 4th minus 9c squared. Wow. That one looks really complicated. Super bad. First of all, is this a difference of squares? Is 81v to the 4th, is that a perfect square? If the exponent is an even number, if it can be evenly divided by 2, that means it's a perfect square. Because that's what you do with exponents. You split them in half. That's what square rooting exponents means. Okay, and of course, this is a perfect square as well. So go ahead, write the answer down there. Okay, this is what you got for an answer right here? That should be your answer. Just take the square root of each term, put them in there. I'm going to give you one more example that's going to be a little bit tricky. Okay, actually not really tricky. Follow the same process, but I want to see if you guys can actually factor this one. So give me a second here. All right, so here's your last example, and I want you to decide whether this is a difference of squares, and then I want you to factor it fully. Okay. So let's do this first part together. Is it a difference of squares? Yeah, 16x to the 4th is a perfect square. Is 81 a perfect square? Yes. Okay? So go ahead. Take a minute here and factor that fully. Okay, let's walk through this question together. Okay, hopefully you've done this question already. Let's see if you were right. All right, so this is a difference of squares, so I know how to tackle this question. You take a look at 16x to the 4th. And the square root is 4x squared. Put that there and there. 81, the square root is 9. Put that there and there. Okay, and then 1 is a minus and 1 is a plus. Are you done? No. Not done. Now why are you not done? Some of you are shaking your head, you know why. Look at this right here. This is a difference of squares. So when one of your factors is not fully factored, you need to keep factoring. So fully factored means that you have all the factors they're completely done being factored. They're prime. So what we do is this one right here, this just stays as 4x squared plus 9 because we can't factor this one any further. A sum of squares is not the same as a difference of squares. Okay? So there is no kind of neat packaged way to factor this. This is prime. Can't do it. If there's no greatest common factor, then you're done. But with this one, I can factor this again, and it looks like this. Square root, it's a perfect square, so that's 2x, 2x. Square root of 9 is 3, and 3, 1 plus, 1 minus. There is your fully factored form. Okay? So just a heads up, you may have to factor more than once. There may be more than one step involved. Okay? Questions?